talking about here today linear differential equations. So these are different than the separable. These you can't separate the x's from the y's. What these in form will look like is this: y prime plus p of x times y equals q of x, where p of x and q of x, just like they're denoted there, those are just functions of x, expressions involving x. For example, y prime plus 3xy equals e to the x. All right? So we've got the y prime. So this is how these, or how we want to make these look. So we've got the y prime, got the y. So my p of x is 3x, and the q of x is e to the x. So these p of x and q of x, they can be different sorts of expressions. This one's a linear, this one's an exponential, but they can have any sort of shape, just about any sort of shape. Now, sometimes there's a little work involved because this, I'll refer to it as standard form. A linear differential equation may not be in this standard form. We're going to want to put it in standard form because of the way the solutions work here. But for example, let's xy prime plus y equals 2x. That's a linear differential equation. However, it's not in standard form, right? Why not? Well, first of all, we've got the x times the y prime. In standard form, y prime is by itself. And so this isn't a very hard fix to put it in standard form. I would just take this, wouldn't I? Couldn't I just divide everything by x, both sides? And that would get us y prime plus y over x equals 2. And then the y, this is in standard form because the p of x here, I could write that as, just say 1 over x times y equals 2. So yeah, that's my p of x, and that's my q of x. And y prime is side there all to itself. Okay? All right, well, let's ask, then this question is y prime minus y equals 2xy linear. Y prime minus y equals 2xy. Is that one linear? Well, maybe, maybe not. Not all differential equations are linear. May not be. But here is what we can do on this one. This one's a little bit different because notice here I do have the y prime by itself. But what's wrong with this side? Well, this side I don't want y on at all, right? So I just want an x term, an expression in x over here. So what this one amounts to is I need to get the y terms together, so I'm going to move my y term, subtract 2xy from both sides. Then I can factor off here, you can factor off a y minus y and make it, 1 plus 2x equals 0. And so, yeah, there you go. So, yes, it is linear. So I've got y prime, then I've got something times y would be minus 1 plus 2x. The p of x would be minus 1 plus 2x, and then the q of x is 0. So, yeah, linear. Okay? Now, let me make a note about this one, is y prime plus 6xy squared equal y linear. Well, again, the same thing. I've got y prime by itself, but then I've got y over here. However, no need to even go to that bother, because why is this one not linear? Because you got y squared, yeah. And linear is y to the first. That still applies here. Yeah, so if I have y squared, there's no need to maneuver anything around. That's not going to be linear. It's got to be y to the first. You can't have a y squared involved anyhow. Okay? All right. So then it becomes, well, how about solving? That's what we ultimately want to do here. Solving one of these linear differential equations. Well, before I do that, let me start with another aspect here. May have not mentioned before, or may have not seen before. And that is, note this. If I have the integral of something prime, the derivative of something, if I do the integral of the derivative of something, integral and derivative are basically, they're inverses of one another. This would just be a. Let me show you an example. Plus c, there's a constant involved, but say I have this. Well, I can do this, do that first. So that's, what would that be? The derivative of that would be 21x squared. So I'm doing the integral of 21x squared. Well, the integral of 21x squared would be 21 over 3x cubed plus c, which is 7x cubed. So that's what we're saying. If I do the integral of something that's to do the derivative of, yeah, those are just going to cancel out, so to speak, and you just wind up. So it basically cancels one another out. All right, I'm going to use that in just a second. Don't know that I pointed that out before, but I'm going to use that in just a second. All right, here is, let me just write out the formula here for you. All right, so say I've got the linear differential equation, just in general form, y prime plus p of x, y equals q of x. Turns out, to do the solutions to this, first of all, we're going to calculate what's called the integrating factor. I of x is what we'll call it, just the integrating factor. And I of x is going to be the integral, is e to the integral of p of x dx. It's going to be called the integrating factor, I of x. I've seen it called different things, but we're going to call it I of x. And it's going to be e raised to the integral of p of x. Well, what's p of x? P of x is this term here, the term in front, the expression in front of y. Okay? Then we can find the solutions by this little formula here. First of all, find I of x. Then the solutions are given by this formula, y equals 1 over I of x times the integral of I of x times q of x dx. Looks a little complicated, but it's not too bad, really. So the I of x is here, and it's here. And then you simplify it. And that are the solutions to a linear differential equations. I'll refer to this will be our solution equation for linear differential equations. Okay? All right, well, let me start, first of all, with this one. Okay? Keep that one in mind. 1 over I of x, integral I of x q of x. Okay. All right, so let's go to this one. We got y prime plus 3x squared y equals 6x squared. All right. So we first of all start with I of x, and I of x equals the, let's do it right here. All right, so start off with I of x. It is the e to the integral of p of x dx. Well, in this case, what is p of x? Isn't this p of x? P of x is 3x squared. So it'll be e integral 3x squared dx, which that works out pretty nicely, that integral. Wouldn't that integral be, it'll be 3 divided by 3, so it's 1x cubed. And just a note on the plus c here, you know, we'll ultimately have a plus c, but in the interim here, we can just choose whatever c we want, and obvious choice would be 0. So we can do that right here for right now. Okay, so then the solutions are, by that formula, y equals 1 over the I of x times the integral of I of x q of x dx. And so now I can plug in my I of x and my q of x. What have I got? 1 over e to the x squared. Integral of e to the x squared. That's the I of x. What's q of x? Haven't labeled it yet. Q of x is just this expression over here. So q of x is 6x squared dx. Okay? So by the solution equation, that's what the solutions will be. And then we'll, in a moment, I'll go ahead and simplify that. But let me just show you this first one out of the box anyway. Let me just show you how why this works. Okay? Here's why that works. Let's go back to the original. I'll come back to that. Let's go back to the original equation. Y prime plus 3x squared, y equals 6x squared. Let's multiply that by my I of x, integrating factor ex cubed. E to the x cubed. So that would make it e to the x cubed y prime plus e to the x cubed times 3x squared y equals e to the x cubed times 6x squared. Okay. Now, the reason this works is we must note here this left-hand side actually is something very, very nice. That's why we chose this integrating factor. This side right here turns out is, well, it's I of x times y primed, derivative of that. Let me show you. So it's I of x, which is e to the x cubed times y prime. Now, let me show you that this works out to be this. How do I do the derivative of that? It's product rule, right? So I'll do a first times the derivative of the second. Well, the second's just y, so the derivative is y prime, plus the second, which is y, times the derivative of the first, which that would be e to the x cubed times, by chain rule, 3x squared. Look at this. Isn't that exactly that? Well, those switched around. E to the x cubed y prime plus e to the x cubed 3x squared times y. So, what I'm going to do then is, since this is equal to this, I'm going to do that. I'm going to substitute this for that. So that gives me e to the x cubed y prime equals e to the x cubed 6x squared. So I just substitute for this, substitute that. Now let's integrate both sides. which is why I talked about just a second ago, what I talked about, what is the integral of e to the x cubed y primed? Ex cubed y. Okay, yeah. The integral and the derivative cancel out there. All right, and then this is, well, let's just leave it e to the x cubed 6x squared dx. Solve for y, divide both sides by e to the x cubed, and let's do this side like this, and voila, what do we got? Isn't this 1 over ix times the integral of I to x qx dx? Exactly what we had here. Okay. All right. So that's why this works. This factor just turns out to make this side really nice. It turns out to be the derivative of that thing, and so here. All right. So I just wanted to show you that. Now let me go back here then to. So what do we do with that? Which is right here. I'll just go back here. Give me a little more room. All right. So what do we do with this? Well, we continue on. We do the integral here. So it'd be y equals 1 over e to the x cubed. The integral of that. Now, do you see here? This is just a nice little u sub. Do u is x cubed. Du then would be 3x squared dx. And so du over 3x squared is my dx. So make that u substitution. So it'll be e to the u, 6x squared, du over 3x squared. Now the x squared is canceled. The 3 goes into the 6. So I wind up with y equals 1 over e to the x, integral of 2 e to the u du. Now that's just now a simple little antiderivative. It's 1 over e to the x cubed. Sorry, got my cube there. Antiderivative of that would be 2e to the u, wouldn't it? Plus c. Now note there, be sure this factor up here is going to multiply by all that, so don't forget, I use a little parentheses there. So we have y equals 1 over e to the x cubed. Go back to x's, so it would be 2e to the x, 2e to the x cubed plus c. Now what they'll do with that is go ahead and distribute the 1 over e to the x cubed. So I have 2, so 1 over e to the x cubed times 2e to the x cubed plus 1 over e to the x cubed times c. And so we'll write that. Well, nice things happen here on the first one. Those just cancel. That's just 2. And then this one, and you could leave it like that, but make it a little more compact. This is my solutions. My family of solutions to the original linear differential equation. That's my solutions. In other words, if I plug this in for y, and then got its derivative, plugged it in for the derivative, that plus that would give me 6x squared. Okay? All right. Well, let's try another one then. Xy prime minus 3xy equals x squared. Well, the first step on this one, it's not in the exact form I want. I want y prime plus p of x, y equals q of x. That's not what I have here because I've got x y prime. I want to get rid of that x. So just like before, I'm going to divide by x. So that gives me y prime minus 3y equals x. Sometimes we have to do that. Okay. Then our next step is we need that I of x factor. So I can plug that into the solution equation. I of x, remember, is e to the integral of p of x dx. What's my p of x? Well, right here, p of x is what's times the y, which is negative 3. So the e to the integral of negative 3 dx, which is a nice, lovely little integral there, be minus 3x plus c, but I'm going to choose c to be 0. So then my solution, go to my solution equation, 1 over I of x times the integral of I of x q of x dx. What do I got? Well, it would be 1 over I of x, so it would be e to the minus 3x. Integral of I of x is e to the minus 3x. Do that again. Times q of x, which is, what's my q of x? Well, this other side is my q of x, isn't it? So q of x is x. Now it's just a matter of doing this little integral and distributing and all that. Any thoughts? Parts, yeah. Unfortunately, yeah, this one doesn't work out as nicely. It's not due substitution, it's parts. You have to use little parts. U to be x, yeah, because then it'll go away basically for my du. And then v is dv is the rest of it, which is e to the minus 3x dx, which is good because I can just do a nice little integral there. So du here is dx. Integrate, and we get v. A little reminder here. So this is v. Now what about that? That is u substitution right there, isn't it? U equals negative 3 x, so du would be negative 3 dx. Du over negative 3 is dx. And so that would be the integral of e to the u du over negative 3, which works out to be v equals, what would it be, negative 3 e to the u? Negative 1/3 e to the u, which is negative 1/3 e to the negative 3x. Okay, so by parts then, we've got y equals, what is it, uv? U times v. So it'll be x times that. Negative 1/3. Whoop. Don't forget this part. 1 over e to the minus 3x. Then times uv, okay, which is x times negative 1/3 x cubed. Negative 1/3 times e to the minus 3x. Minus the integral, was it v to u? uv minus v to u integral. Which would be minus the integral of v, which is minus 1/3 e to the minus 3x. du is dx, yeah, so that's really nice. So 1 over e to the minus 3x minus 1/3 x to the minus 3 e to the minus 3x. Minus minus, we have plus. The rest, though, I think I'm going to have to do another little u substitution, kind of like the one before. All right, so that is, so I have 1/3 e to the u du over negative 3. And so it winds up being 1 over e to the minus 3x times negative 1/3 x to the e to the minus 3x plus 1/3 times negative 1/3 basically, so that'll be a negative 1/9 e to the u is negative 3x plus c. With me on that? 1/3 minus 1/3 x to the negative 3x minus 1/9 e to the minus 3x plus c. Now to clean this up, it is going to clean up nicely if I multiply all that in there. Y is just going to be, so if I multiply this, well, let's go ahead and denote all this. So times that one, The e to the minus 3x are going to cancel. Same thing will happen here. And then 1 e to the minus 3x times c. So I'll wind up with negative 1/3 minus 1/9 plus, and then on this one, can I write, what happened to my x? 1/3 minus 1/3 x minus 1/9. Can I write this as e to the 3x? I didn't do that before since all those were going to cancel out. They're my solutions. Negative 1/3 x minus 1/9 plus e to the 3x times c, or c e to the 3x's. Probably they would write this as c e to the 3x. Okay? All right. Let's solve question.
If you had e to the negative 3x, how did it go down there?
Right here? Yeah, that's what I was saying. E to the minus 3x, if I flip it up, it'll make it a positive.
Where did this come from? Because it looks like the step before you had e to the 3x.
Yeah. Okay. So yeah, when I multiply this one, these cancel out. When I multiply this one times this one, those cancel out. So I didn't write that out. And then when I multiply that one, I get 1 minus e to the 3x times c. Yeah. And then it flips up. Okay, one more here I think will suffice, hopefully. xy prime plus y equals x squared. On this one, though, I'm going to say x greater than 0, restrict it there, and it's going to have initial condition on it, y1 equals 3. So in other words, for this one, I want to find a particular solution, not the family. I want to find the particular. Okay? And you'll see why I do this one. X greater than 0 in just a second. All right. Well, it is a linear, but it's not in the standard form. Again, I need don't I need to divide by x? Matter of fact, I might have had this one a while ago. Y prime plus, that'll be 1 over x times y, let's put it in that form, equals x. Yeah, I think that was the one I did earlier. So this is my p of x. This is my q of x. What's my I of x? It's e to the integral of p of x dx. And so that would be e, p of x is 1, okay, so it would be integral 1 over x dx. So I need to do the integral of 1 over x, which is natural log of absolute value of x, however, e to that. However, since I'm doing greater than 0, that doesn't change anything. It's just ln of x, isn't it? So it's e to the ln of x, which even works out nicer because e to the ln, don't those cancel? And you have e to the ln power. E and the ln power cancel, so that's just x. So it worked out pretty nicely there. And so my solutions then will be y equals, it's 1 over I of x times the integral of I of x q of x dx. So, yeah, it's just 1 over x here, isn't it? Times, yeah, I of x, we don't have the e in this case, so yeah, just x. And then q of x, it's just x. Oh yeah, that is really nice. Q of x is just that, so that's just y equals 1 over x, integral of x squared dx, which is 1 over x times 1/3 x cubed plus c. The only thing is I do need to distribute there. So I get y equals 1 over x times 1/3 x cubed plus 1 over x times c. So cleaning that up, won't that be 1/3 x squared plus c over x, we could say? Because the x, that'll cancel into that. 1/3 x cubed plus c over x. That would be the family solutions. But I want the particular solution with this initial condition. I want to find the c there for that. Yeah, so this just means x is 1, y is 3. So plug that in. We've got y is 3, x is 1. So that's 3 equals 1/3 plus c. C minus 1/3. 3 minus 1/3 is c, which is 8/3. So the particular solution I want is y equals 1/3 x squared plus c, which is 8/3, over x, which I could clean that up, say 1/3 x squared. Wouldn't that be 8 over 3x? Is my y. Particular solution.